An ancient comet explosion created vast patches of glassy rock in the Atacama Desert in Chile 12,000 years ago. We know what else happened 12,000 years ago, about 14,000 years ago. The comet impact that put an end to the Clovis culture. So this one was 12,000 years ago in the Atacama Desert of Chile. 12,000 years ago, something scorched the vast swath of the Atacama Desert in Chile with heat so intense that it turned into glass. It turned the sandy soil into widespread slabs of silicate glass. Now a research team studying the distribution and composition of those glasses has come to conclude that it was caused by an inferno. This is by a study from Brown University scientists. The study is published in the journal Geology. This is today's article on phys.org. Researchers show that samples of the desert glass contain tiny fragments with minerals often found in rocks of extraterrestrial origin, that is, a celestial body. Those minerals closely match the composition of material returned to Earth by NASA's Stardust mission, which sampled the particles from a comet called Wild 2. The team concludes that those mineral assemblages are likely the remains of an extraterrestrial object, most likely a comet, that streamed down after the explosion that melted the sandy surface below. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. This is the first time we have clear evidence of glasses on Earth that were created by the thermal radiation and winds from a fireball exploding just above the surface, said Pete Schultz, professor emeritus in Brown University's Department of Earth, Environmental and Planetary Sciences. He says to have such a dramatic effect on such a large area, this was a truly massive explosion. Lots of us have seen bolide fireballs streaking across the sky, but those are tiny blips compared to this. The glasses are concentrated in patches across the Atacama Desert east of Pampa del Tamarugal. It's a plateau in northern Chile, nestled between the Andes Mountains to the east and the Chilean coastal range to the west. Fields of dark green or black glass occur within a corridor stretched about 75 kilometers. There's no evidence that the glasses could have been created by volcanic activity, he said. And this is one of his pictures of the Atacama Desert, and you can see the black spots there are actually the black glass that was formed from the explosion of the comet over the Atacama Desert. The black patches. So the glasses are concentrated in patches across the Atacama Desert. Fields of dark green or black glass occurred within the corridor stretching 75 kilometers. No evidence that the glasses could have been created by volcanic activity, Schultz says, so their origin was a mystery. Some researchers have posited that the glass resulted from ancient grass fires, as the region was not always a desert. During the Pleistocene epoch, there were oases with trees and grassy wetlands created by rivers extending from mountains to the east, and it's been suggested that widespread fires may have burnt hot enough to melt the sandy soil into large glassy slabs. But the amount of glass present, along with several key physical characteristics like simple fires, an impossible formation mechanism, and new research found, the glasses show evidence of having been twisted, folded, rolled, and even thrown while still in molten form. That's consistent with a large incoming meteor and airburst explosion, which would have been accompanied by tornado force winds. The mineralogy of the glass casts further serious doubt on the grass fire idea. Schultz says. And along with researchers from the Fernbank Science Center in Georgia, Chile's Universidad Santo Tomas, and the Chilean Geology Mineral Service, Schultz and colleagues performed a detailed chemical analysis of dozens of samples taken from glass deposits across that region. The analysis found minerals called zircons that have thermally decomposed to form babelite. That mineral transition typically happens in temperatures of an excess of 3,000 degrees Fahrenheit, far hotter than what could be generated by glass fires, Schultz says. The analysis also turned up assemblages of exotic minerals only found in meteorites and other extraterrestrial rocks, the researcher said. Specific minerals like cubanite, troilite, and calcium aluminum rich inclusions matched mineral signatures from COMET samples retrieved from NASA's Stardust mission. Those minerals are what tell us, Scott Harris said, they're what tell us that this object has all the markings of a comet. Harris is a planetary geologist at Fernbank Science Center and the study co-author. He said to have the same mineralogy we saw in the Stardust samples and trained in these glasses is really powerful evidence that what we're seeing is a result of a cometary airburst. More work needs to be done to establish the exact ages of the glass, which would determine exactly when the event took place, Schultz says, but the tentative date puts the impact right around the time that large mammals disappeared from the region. That's a Clovis comet then. Mammals, the large woolly mammoths that disappeared from North America, for example, was the Clovis comet about 14,000 years ago. He said it's too soon to say if there was causal connection or not, but what we can say is that this event did happen around the same time as when we think the megafauna disappeared, which is intriguing. Okay, the megafauna was about the Clovis comet about 14,000 years ago. I guess here they meant 12,000 BC. Anyway, going back to this, he says there is also a chance that this was actually witnessed by early inhabitants who just arrived in the region. It would have been quite a show. Schultz and his team hope that further research may help to constrain the timing and shed light on the size of the impactor. For now, Schultz hopes that the study may help researchers identify similar blast sites elsewhere and reveal the potential risk posed by such events. There may be lots of these blast scars out there, but until now, we have not had enough evidence to make us believe they were truly related to airburst events, Schultz says. I think this site provides a template to help refine our impact models and will help to identify similar sites elsewhere. Other authors of the study are Sebastian Perrault, Nicholas Blanco, and Andrew Tomlinson. And this was from Brown University on phys.org, today's article. Please leave your comments. Thank you for your support.